Hello everyone. In this video, I shall discuss the solution of question number 49 of GATE Physics 2019. This is a numerical answer type question. In a thermally insulated container, 0.01 kg of ice at 273 Kelvin is mixed with 0.1 kg of water at 300 Kelvin. Neglecting the specific heat of the container, we need to find out the change in the entropy of the system in joule per Kelvin on attaining thermal equilibrium. Let's solve this question. In this question, we have heat released by water at 300 Kelvin equal to heat absorbed by ice at 273 Kelvin. Now let's find out the latent heat absorbed by ice. This is equal to m1 into L, where m1 is the mass of ice, which is equal to 0.01 kg, and L is equal to 335 kilojoule per kg. So we found that the latent heat absorbed by the ice is equal to 3.35 kilojoule. Now let's consider that the final temperature on attaining the equilibrium is equal to Tf. The temperature T1 is equal to 273 Kelvin and the temperature T2 is equal to 300 Kelvin. We have heat absorbed by ice at 273 Kelvin equal to heat released by water at 300 Kelvin. This equation can also be written as the latent heat absorbed by ice plus heat absorbed by water at 273 Kelvin equal to heat released by water at 300 Kelvin. The latent heat absorbed by ice is equal to 3.35 kilojoule as we have derived before, and the heat absorbed by water at 273 Kelvin equal to m1 into S into Tf minus T1, and the heat released by water at 300 Kelvin is equal to m2 into S into T2 minus Tf. Here m1 is equal to 0.01 kg, m2 is equal to 0.1 kg, T1 is equal to 273 Kelvin, T2 is equal to 300 Kelvin, and the specific heat S is equal to 4.2 kilojoule per kg into Kelvin. Putting these values and after doing some simplification, we finally obtain that the final temperature is equal to 290.29 Kelvin. Now let's find out the change of entropy in melting of ice. This is equal to delta S1, which is equal to delta Q1 by T1. Here delta Q1 is equal to M1 into L. Putting the values of M1, L and T1, we obtain that the change of entropy in melting is equal to 0.012271 kilojoule per Kelvin. This can also be written as 12.271 joule per Kelvin. When the temperature of water is changed from T1 equal to 273 Kelvin to Tf equal to 290.29 Kelvin, then the change of entropy delta S2 is equal to the integral dq by T. Here dq can be written as m1s into dt. Here the limits of the temperature T are T1 and Tf. So you obtain the change of entropy delta S2 is equal to m1s into log Tf by T1. Putting the values of m1, s, Tf and T1 and after doing some simplification, we obtain that delta S2 is equal to 0.002579 kilojoule per Kelvin. This can also be written as 2.579 joule per Kelvin. When the temperature of water is changed from T2 equal to 300 Kelvin to Tf equal to 290.29 Kelvin. Then the change of entropy delta S3 is equal to M2S log Tf by T2. Putting the values of M2, S, Tf and T2, and after doing some simplification, we obtain that delta S3 is equal to minus 0.013819 kilojoule per Kelvin. This can also be written as minus 13.819 joule per Kelvin. So the total change of entropy delta S is equal to delta S1 plus delta S2 plus delta S3. Here delta S1 is equal to 12.271 joule per Kelvin, delta S2 is equal to 2.579 joule per Kelvin, and delta S3 is equal to minus 13.819 joule per Kelvin. So the total change of entropy is equal to 1.031 joule per Kelvin. But in this question we need to write the correct answer up to 2 decimal places. So the correct answer is 1.03 joule per Kelvin. So in this question the correct answer is 1.03.